Hello, so today we're going to talk about how to solve an absolute value equation and an absolute value inequality. Like with our linear equations, linear inequalities, the process between the two of them are very similar. But let's first talk about the idea of what an absolute value really is. So the absolute value will always give you the positive of whatever the number we're dealing with. So for example, absolute value of 7 is 7. The absolute value of negative 7 is also 7. And the reason why it's giving us this positive result is because absolute value is really the distance a point is from 0. So distance is never a negative concept. That's why the absolute value of negative 7 equals positive 7. Because negative 7 is 7 spaces away from 0. Now, because of the nature of absolute value, it will never result in a negative number. For example, absolute value of x can never equal a negative 5. It doesn't make any sense. If it was positive 5, then that's okay. But the expression can never equal a negative number once the absolute value is all by itself. Now, the way we solve an absolute value equation is we have to set up two different equations. We set the expression that's inside equal to both the positive and negative results of the outside, where we don't change anything about the inside expression in the slightest. So again, that's going to give us two different answers, the positive and negative. But do keep in mind, again, if the absolute value expression equals a negative from the very beginning, before we move things around and separate it, then the answer has to be no solution, because the absolute value cannot result in a negative number. So what I mean by that is this right here. So if the absolute value of w minus 9 equals positive 17, because the equation equals a positive number, we can now separate out the absolute value, where we set the inside, w minus 9 equal to 17, and we set the inside w minus 9 equal to negative 17. So now we have two different linear equations. We're going to solve them both. In both cases, we have to add 9 to both sides. So when we add 9 to 17, we get 26. When we add 9 to negative 17, we get negative 8. So both those numbers represent two different answers. W is equal to negative 8 and 26. You can write them separate like that, or you can write them together, w equals negative 8, comma 26, to write your answer in that form. Both are perfectly acceptable. But if we notice, again, the absolute value of a negative number makes it positive, but the w minus 9, we do not change the expression from negative to positive. The expression itself won't change. What does change is the number on the outside. That's why we use a 17 and a negative 17. So we have something like this. Now we have multiple numbers going on. Like with our linear equations, the whole idea behind solving an absolute value expression is to get the absolute value portion all by itself, which means anything that's not in the outside of the absolute value needs to move to the right-hand side of the equation, or the left-hand side, depending upon where your absolute value is. So for this example, we have to subtract 8 first. So it's 2, absolute value of 3x minus 4, equal to negative 2. We then divide by the 2. The absolute value of 3x minus 4 equals negative 1. Now that we've isolated the absolute value, we can now talk about solving it. Where if we notice, the absolute value equals a negative number. This cannot happen. So then therefore our answer is just simply no solution. You might see the textbook or other videos or anyone else using this symbol right here. Like an O with a line through it, that just simply means no solution. Had that equal a positive number instead of the negative one, we would then simply separate out and solve it from there. Now, if the absolute value equation equals an expression, it's still the same general idea. The key is making sure there's nothing left over on the same side of the equation as the absolute value expression. Once that's true, like in this case, there's nothing on the left-hand side besides the absolute value, we can separate it out. Whereas we saw with the numbers, it's equal to the positive, so nothing changes, negative 6y plus 4, and it equals the negative, 4y plus 12 equal to the negative of negative 6y plus 4. So two different answers, the positive and negative of the results. That's why we have to do the negative of the expression, negative 6y plus 4. So in the left expression, we add 6y to get 10y. Subtract 12 to get negative 8. Divide by 10, we get negative 8 tenths, which reduces to a negative 4 fifths. Whereas on the right side, we take care of the negative part first, so it's really then positive 6y and negative 4. So when we subtract 6y over, we get negative 2y. Subtract 12, we get negative 16. Divide by the negative 2 to get a positive 8. So then that tells us that we have either two possibilities, negative 4/5 or positive 8. Now, where you need to be careful with absolute value is this part right here. If the absolute value equals an expression, it's negative 6y plus 4, rather than just simply a number, we do need to plug these answers back into the equation to make sure they actually give us correct answers. Because, for example, if we plug in the 8 into the expression, we have 4 times 8 plus 12 equal to negative 6 times 8 plus 4. So we get absolute value of 32 plus 12, which is 44. Whereas on the right side, we get negative 48 plus 4, which is negative 44. That does not work. So then in reality, this is not a solution, the y equals 8 parts. And then we plug the negative 4/5 back into the equation, so we have 4 times a negative 4/5 plus 12 equals negative 6 times negative 4/5 plus 4. Let's see, we get negative 16/5, and then 12 will be 60/5, which gives us a positive 34/5. Or on the right side, we get 24/5. We'll rewrite the 4, I'm sorry, not 34, 44/5. That's my mistake. We'll get 24/5 plus 20/5, which is also 44/5. So we see that's okay, so that means the negative 4/5 wasn't a correct answer. I kind of want to say that for the most part, when it's absolute value equals an expression, you're only going to have one answer, and it's only going to be only equal to the original expression itself, not the negative of the expression. However, it is possible to get two different answers for something like this. So you always need to just simply try it out, just simply check it to make sure if what you did is correct. So yeah, like I said, always make sure you plug them in. I'm sorry, I had to pause the video. I just want to do some double checking to make sure I wasn't giving you wrong advice. Always plug them in. There are some cases where two answers will work, so don't assume both answers don't. So always make sure you plug them in just to check. If you assume both answers work and only one does, and you turn something in like that in, you're going to be getting some questions wrong. Okay, so absolute value inequalities is the exact same process. The only difference is when you do your negative results, you'll have to flip the inequality sign, similar to when you dealt with linear inequalities and you divide by a negative number. So that looks like this. So again, we have the absolute value of 3b plus 5 greater than 14. So we'll say 3b plus 5 is greater than 14, and then 3b plus 5 is less than negative 14. Again, we use the negative result, but we also flip the inequality sign. Again, we still solve the same way. So when we subtract 5, we get 3b is greater than 9. So b is greater than 3. Subtract 5, we get 3b is less than negative 19. So b is less than negative 19/3. Now, with absolute value inequalities, it's important to make sure you either write the solution as an OR statement or the conjunction, which is the compound inequality. In this case right here, we can't combine it to a single expression because b is both greater than 3 and it's less than negative 19/3. So this is an OR case. b greater than 3 or b is less than negative 19/3. If we found something like, for example, b less than 2, the other one's like b is greater than negative 5, b can be in between those two numbers, so be in between negative 5 and 2. So if you're ever unsure whether you actually can combine it or not, just simply set it up. So in this case, it would be negative 19/3 less than b less than 3. If you compare that based off your original answers, it's like, wait a minute, that doesn't fit. That's why we can't do it. Alright, so like with the equation, same idea. If the absolute value expression is not isolated, we do need to isolate it. So we have to move the 8 over. So we get 6, absolute value of 4p plus 2, less than 42. And we divide by the 6, so absolute value of 4p plus 2 is less than 7. Because it's a positive number, we can solve this out. So we'll set for two expressions. 4p plus 2 is less than 7, and then 4p plus 2 is greater than negative 7. So we subtract the 2, we get 4p less than 5, p is less than 5/4. Whereas here we subtract by 2, we have 4p greater than negative 9, so p has to be greater than negative 9/4. So if we try and combine them, putting the smaller number first, negative 9/4 less than p less than 5/4, and we compare that to the original expressions, p less than 5/4, p less than 5/4. P is greater than negative 9/4, so it is. So this is a conjunction example. You'll generally find for the most part, if the absolute expression is less than a number, you can write as a conjunction with two compound inequalities, whereas if it's greater than a number, then it has to be an OR in that case. But always just simply set up just to make sure whether you can combine them correctly or not. Now there are some special cases to the absolute value inequalities similar to the absolute value equations. We still isolate the absolute value expression, so we still subtract the 14. 2 times absolute value 3x minus 5, greater than or equal to negative 6, divided by the 2. Absolute value 3x minus 5 is greater than or equal to negative 3. Now, we see we have a negative on the outside. Had this been an equation, the answer would be automatically no solution. However, with absolute value inequalities, there's either two answers, either no solution or all real numbers. It depends on the inequality sign. Because while the absolute value can't be a negative number, that's why I can't equal it, it always gives us a positive. So the question we want to ask, is a positive number greater than or equal to a negative number, negative 3? Since the answer is yes, it is, this is actually all real numbers. Or infinite solutions. Both are acceptable ways of writing it. Again, the rationale is because the absolute value always results in a positive no matter what. In this case, we're saying positive is bigger than negative, and that's okay. That's certainly true. That's why it doesn't matter what x is. It will always result in a true statement. Whereas the opposite is true. If we have the absolute value is less than a negative number, we have to ask ourselves, okay, is positive less than negative 5? Since positive is never less than negative, no, our answer is simply no solution. So the equations for absolute value, if it equals negative, automatically no solution, you're done. If it's an inequality, look at whether it's less than or it's greater than. That'll tell you whether it's no solution or all real numbers, infinite solutions. Okay, so that's it for absolute values. So I'll see you with the next video.